Hello friends, Rahul Jha welcomes you. Today we are going to talk on hydrogen combustion engine. So let's start. How does hydrogen combustion engine works? A hydrogen combustion engine is similar in principle to a traditional internal combustion engine that runs on gasoline or diesel. However, there are some key differences in the fuel and combustion process. Here is a basic overview of how a hydrogen combustion engine works. Fuel storage and injection. Hydrogen is stored in a high pressure tank as a compressed gas or in a liquid state. The hydrogen is then injected into the combustion chamber of the engine. Air intake. Like conventional engine, a hydrogen combustion engine pulls in air for combustion. The air and hydrogen mixture must be within a specific ratio for efficient compression. The air-hydrogen mixture is compressed in the combustion chamber by the engine piston. The compression increases the temperature and pressure of the mixture, preparing it for ignition. Unlike traditional engines that use spark plugs for ignition, hydrogen combustion engine often uses spark plug or other ignition system suitable for hydrogen. Hydrogen has a high ignition energy requirement, so special ignition system may be needed. Conclusion. When the air-hydrogen mixture reaches the right condition, ignition occurs. Hydrogen combusts in the presence of oxygen, producing water vapor and the primary byproduct. The combustion process generates heat and pressure, forcing the piston down. Power generation. The movement of piston is converted into mechanical energy which drives the engine crankshaft. The crankshaft in turn powers the vehicles or other machinery connected to the engine. Exhaust. The main byproduct of hydrogen combustion is water vapor, making hydrogen combustion engine relatively cleaner in terms of emission. The water vapor is expelled through the exhaust system. It is important to note that while hydrogen combustion engines have some advantages in terms of cleaner emissions, they also face challenges such as energy-intensive process of producing and storing hydrogen, as well as the need for specialized infrastructure. Additionally, hydrogen is often considered more as a fuel for fuel cell in electrical vehicles, where the chemical reaction with oxygen produces electricity directly rather than through combustion. How vehicle moves with this hydrogen engine. The vehicle equipped with the hydrogen combustion engine moves in a manner similar to vehicle with traditional internal combustion engine. The hydrogen engine generates power through the combustion of hydrogen, and this power is used to drive the vehicle wheel. Here are some more detailed explanation of how the vehicle moves. Power generation. The hydrogen combustion engine produces mechanical power through the combustion of hydrogen and subsequent movement of engine's piston, crankshaft and transmission. The mechanical power generated by the engine is transmitted to the vehicle crankshaft. The crankshaft converts the linear motion of piston into rotational motion. Transmission system. The rotational motion from the crankshaft is sent through the vehicle's transmission system. The transmission system may include a gearbox that allows for the adjustment of vehicle's speed and torque. Drive mechanism. The rotational motion is then transferred to the vehicle wheels through a drive mechanism such as drive shaft for the series of gear. While rotation, the power reaching the wheels causes them to rotate. The friction between the tires and the road surface allows the vehicle to move forward or backward. Vehicle movement. As the vehicle rotates, the vehicle moves in the direction determined by the driver's input through the steering wheel and pedals. Acceleration and deceleration are controlled by varying amount of hydrogen fuel, injected into the combustion chamber, adjusting the engine power output. The overall process of converting the chemical energy into hydrogen into mechanical energy and ultimately into the movement of vehicle is similar to the operation of traditional internal combustion engine. The main difference lies in the fuel used, that is hydrogen, and the cleaner nature of the combustion byproduct, which is water vapor. It's worth noting that while hydrogen combustion engine exists Hydrogen fuel cells are also popular technology for powering electrical vehicles, providing a different approach to utilizing hydrogen for transportation. How much pollution is created by this engine? Hydrogen combustion engines produce fewer greenhouse gas emissions and air pollutants compared to traditional gasoline or diesel engines. When the hydrogen undergoes combustion engine in an engine, the primary byproduct is water vapor, that is H2. This makes hydrogen combustion a cleaner option in terms of local air quality and greenhouse gas emission. However, it is important to note a few considerations. Water vapors. While water vapor is a much cleaner emission compared to the pollutant from the traditional engine, in certain conditions and in large quantities, water vapor can contribute to localized environmental effects. For instance, in extremely cold climates, water vapor emissions could contribute to visible condensation trails of cloud. Production of hydrogen. The overall environmental impact of hydrogen combustion engine depends on how the hydrogen is produced. If the hydrogen is derived from renewable sources through the process like electrolysis using clean energy, the overall environmental impact can be low. However, if hydrogen is produced from natural gas through a process called steam methane reforming, it can result in carbon dioxide emission. Energy efficiency. The efficiency of entire clean energy chain from hydrogen production to combustion in an engine also plays a role in environmental impact. If the overall process is energy intensive, it may offset some of the environmental benefits. Emission controls. The design and implementation of emission control technology in hydrogen combustion engine can influence their environmental performance. Advanced engine technologies and control system can further reduce emissions. In summary, hydrogen combustion engines have potential to be cleaner alternative to traditional internal combustion engine, particularly when the hydrogen is produced using renewable energy source. However, the overall environmental impact depends on various factors, including the source of hydrogen, the efficiency of production process, and the emission controls measure implemented in the engine design. Is this best option for future? Determining the best option for future depends on a variety of factors, including technological advancement, infrastructure development, energy efficiency, and environmental consideration. Hydrogen combustion engines are one of the many technologies being explored as part of translation to more sustainable and low emission transportation solution. However, whether it is best option depends on specific contexts and goals. Here are some considerations. Cleaner emissions. Hydrogen combustion engines produces water vapor as a primary emission, which is much cleaner than the pollutant emitted by a traditional internal combustion engine. This can contribute to improved air quality and reduce greenhouse gases emissions. Energy efficiency. The overall energy efficiency of hydrogen production process, storage, and utilization in combustion engine is a crucial factor. The more efficiently the entire hydrogen supply chain operates, the better it is for the environment. And infrastructure development. The development of robust hydrogen infrastructure include production, distribution, and refueling stations is essential for widespread adoption. Currently, the hydrogen infrastructure is less developed compared to other alternatives such as electric charging infrastructure. Hydrogen sources. The environmental impact of hydrogen combustion engine is influenced by the source of hydrogen. Green hydrogen produced using renewable energy source is more environmentally friendly than grey hydrogen, which is produced from natural gas. Alternative technology. Other technologies such as hydrogen fuel cells and battery electric vehicles are also developed for transportation. The choice between these technologies depends on factors like energy density, vehicle range, and application. Policy and regulations. Government policies and regulations plays a significant role in shaping the future of transportation. Incentives and regulations that promote cleaner technologies can influence the adoption of hydrogen combustion engine. Consumer acceptance.
The acceptance and willingness of consumers to adopt hydrogen combustion engine vehicles are crucial. Consumer preferences, convenience, and perceptions about the technology can impact its success. It's worth noting that future of transportation is likely to involve a mix of technologies, and the best solution may vary depend on specific use cases and regional consideration. Many experts envision a future where multiple technologies including battery electric vehicles, hydrogen fuel cell and advanced combustion engines coexist to address different transportation needs and contribute to more sustainable and low carbon future. So that was all. Thank you.